We're going to talk a little bit about hyperbolas here. And so I've started here with an ellipse. Here, let's hide this so you don't have to look at that. I've started here with an ellipse, and you can see that the equation here, it's shifted over to the right 3, and it's shifted down 2, that the length of the minor axis would be 8, and that the length of the major axis would be 10, because if you took a look, that the distance from here to the center would be 5, and then from the center down would be another 5. So these are things that we already know about ellipses. Now, it turns out if you take this positive number and you make it negative, this turns into a hyperbola. And so a hyperbola has 2 branches. You can see one here to the left, one here to the right. It sort of looks like 2 parabolas, but the shape is not exactly the same. And so the cool thing is that if you make it negative, you can see that it hugs what the ellipse would have been. And if you take this negative here and you put it in front of the x value, it just flips the other way. And so you've got these 2 different types of hyperbolas that can be created off of what would have been an ellipse. So if I start again with the ellipse and I just take the y and I make it negative, it turns out that it opens up along the x-axis. So what we call the transverse axis, if you take a look at what you see in your textbook, this first equation here, the transverse axis would be horizontal. And so that transverse axis, as you see here in this picture, is this axis that goes through the vertices and goes through the center. And so in our equation here, that would be this horizontal transverse axis right here. Now, if I switch the negative and instead I put a negative in front of the x, it looks like this opens up the y-axis, and I've got a transverse axis that's vertical. So the shifting, you can still see, over 3 and down 2 is where the center of this thing would be, right around here. And so that point is where this thing is going to be centered. So if I take a look at the general equation, which I've put in here, and I've got no shifts on the on the h and the k, and I've got my a value of 1 and my b value of 4. So this one I've happened to make negative here, and you can see that the x is negative, and so that it's opening up along the y-axis. So the h and the k are where the center is, and since the center is here at 0, it's not being shifted at all. But you'll see that the 4 here, this b value, is what the distance from the center is. And so if you take a look, you can see if I change this, then the distance from the center is changing. If I make it 1, it's, b squared is 1, it's 1 unit away. If I were to take b squared and make this 4, so you can see that the distance would be 2. So this a value just changes how kind of stretchy the hyperbola is. It doesn't change how far away it is, so I can just make it really stretchy or not stretchy at all. You see that when it goes negative, it still stays the same. You'd think, oh wait, if it's going negative, shouldn't it turn back into an ellipse? And the answer is no, because you're squaring this a value. So anyways, I'm going to put this back at 1, and I'm going to let these sliders run here. And so if I take this and play it, you can see that the a, again, it takes it and makes it flatter, because in this case, the a is underneath the x, and it kind of pairs up with the transverse axis. Now, if I were to take this equation, instead of making it ellipse, I go and make it negative. You can see that it flips and it opens up the other way. And so now the a value actually talks about how far away from the center it is. Before, that was b. And so really it's just dependent on which one, what the transverse axis is, which way it's opening. And so since the a is underneath the x, and it's opening up around the x-axis, that's the one that's going to affect how far away it is. The b in this case is opening up, it's not opening up, but is underneath the y, and so that's just going to talk about how sort of stretchy it is. So it really matters, which is your transverse axis and which way these branches are opening. The h and the k just shift it left and right, just like any other shape, and so I can hit k and it'll start going at a diagonal now. If I stop the h, it should just shift up and down. And so you can see that these shifts just do that. So if I stop it here, I've got it sort of somewhere centered. So again, it's important to know that what these things do, just like in an ellipse, where that, if I pull this ellipse back up, that the distance from the center to the smaller axis here is 4, because you can tell from that in a hyperbola, the distance here, again, you can see is dictated by this a value, since it opens up the x-axis, and that's underneath the x. But if I were to switch it and make this positive and make this negative, now the b value is what's going to dictate how far away from the center it is. And you can see that because it's underneath the y, and this is opening up the y-axis. And so it's pretty consistent there. So just a couple things to show you. I mean, we've got our standard equations here. The other things that we're going to be able to find are the focus of this, which is really one of the most important things. Other than figuring out how else to graph this, the focus is really important. And so when we found the focus of an ellipse, it was c squared equals a squared minus b squared. And so again, the sign just flips for this one. And if we want to look at where that comes from, we can when we are in class. But just in general, if you want to find that value, it's very, very similar to an ellipse. It's just the sign flips. And so it's important to note that for a lot of the stuff that we're doing with hyperbolas and ellipses, the signs are just flipped, and it creates a different type of shape. So the transverse axis, again, is important to be able to look at from an equation. If you see here, the x is squared, and so the minus is in front of the y. That's going to make it look like something like this, where the transverse axis is horizontal. The transverse axis would be vertical if the x was negative, and you can see an example of that here, the transverse axis being vertical. So another thing that we'll look at how to find in class are the asymptotes. And so if you want to graph this thing and actually look at it, there's a lot of letters here, and so don't freak out. But the asymptotes are really how you can look at on paper, how stretchy or how not stretchy this is. And so there are some examples and stuff that we can look at, in our book. If you take a look at our schedule, we've got examples here are the kind of things that you should be able to do. And so if I take a look at those in here in our textbook, you can see that there's some stuff with matching. And so these are the kind of things that you could really do now after watching this explanation, looking at what the transverse axis is and trying to look at what the shifts are. We've got some examples here where you have to complete the square, and you're turning the general equation into the standard equation for a hyperbola. And then these are the kind of things that you might not be able to do yet, but that we will be able to do, in class when we talk about this. Finding standard equations given some information, given the asymptotes, or given a general equation. And so that's it for the general intro. So I'm going to share this document with you so you can play with it if you want to, and all the equations are loaded in here. And you have that as something that you can access as well.